So we have to do this task, that is find the unit tangent vector, unit normal vector, binormal, curvature and osculating circle for this curve at t equals pi over 2. So for the unit tangent vector, you know what it will be. It is, first we will take dr dt, okay, which will be in the direction of the tangent. So we got dr dt equals how much? If you differentiate, if we got negative sine t, okay, then cosine t, and then simply 2, okay. And if you look at the magnitude of this vector, what that will be simply the square root of sine square t plus cosine square t. Let me just type it fast. Okay, so sine square t, then plus cosine square t, and then plus how much? Square of 2. Now since sine square t plus cosine square t is 1, this becomes a square root of 5. All right. So what is the unit tangent vector then? dr dt divided by or multiplied by the reciprocal of the magnitude. So that will be simply 1 over square root of 5. I mean, you may write a square root of 5 over 5 if you would like. And that's the unit tangent vector. All right. Now for the unit normal vector, what you have to do now is that you shall simply take the derivative of the unit tangent vector and then multiply by the reciprocal of the magnitude. So here, if we take the derivative, what do we get? We get simply negative cosine t, negative sine t, and then here we get a 0. And if we go ahead and take the magnitude of this vector, what do we get simply is, that is, since cosine square t plus sine square t is 1, this will simply reduce to how much? 1 over square root of 5. All right. So our normal vector would be how much? That would be simply, this vector divided by the magnitude. So 1 over square root of 5 will cancel. And that's what we get for the unit normal vector. Now for the binormal vector, now B is simply t cross n. All right, so that is the cross product of t with n. So cross product of this vector with this. I'll do the substitution. T equals pi over 2 in a minute. Okay, so this is going to be how much then? We just let 1 over square root of 5 stay outside, and then we will have a 3 by 3 determinant. Okay, 3 by 3. Okay, and we got I, J, K, and then we got negative sine t, cosine t, and then we got a 2, then we got negative cosine t, then negative sine t, and then we got a 0. So what will this become is, this will simply be 1 over square root of 5, and then we will just write the components. And so what happens, the first component will be this determinant, so that simply is going to be how much? 2 sine t, right? And for the second component, what we have is, we'll ignore this, that will be negative of this determinant, that will be 2 cosine t, okay? And then for the third part, what we get, sine square t plus cosine square t, that simply equals 1. So this is our unit binormal vector. Now for the curvature, we know that one of the ways to obtain curvature is take the rate of change of the unit tangent vector according to arc length, which we can just decompose as dt times how much? dt over ds. Okay. Now what is this dt ds? Notice this. This quantity here, no, not this one, sorry. This quantity right here, you may also call it ds dt, right? So that's what we did when we went through the motion, right? So this is ds dt, which happens to be square root of 5. So dt ds would be 1 over square root of 5. That's a scalar quantity. And this vector, this is how much you just found. This vector here is the value of this again is simply that, and the magnitude of this is 1, so the whole thing is going to be how much? It will be fixed, and of course for a helix it will be this 1 over 5. So the curvature is 1 over 5 at any point, and for the oscillating circle the radius is how much? The reciprocal of the curvature, that is 5. Okay, so now let's go back to just the point that where we want to obtain all these vectors, that is let's call that the point P. Okay, so if we substitute t equals pi over 2, what do we get? We get 0, we get 1, and the z coordinate is how much? That is simply pi. So this is the point at which we are going to write our calculations. And then if we bring our t in here, let's bring t and n. Okay, so t is simply this. T is going to be here at, actually, let me just write these down just to avoid further confusion. Pi over 2, then pi over 2 again. All right. So sine of pi over 2 is 1, cosine of pi over 2 is 0. So the whole thing becomes how much then along t? That will be negative 1, 0, and then 2. All right. And then let's go ahead and bring our n. So now for n, we have this. So what we will do is that we shall evaluate it at pi over 2. It's going to take me longer to write than for you to just see that value right in your head. So that is going to be how much? That is simply going to be, that is 0, and then negative 1, and then 0. And then for the binormal, what we have is, we can either take the cross product of these two or just go ahead and look right here. That is when t is pi over 2, that is 1. This is 0, and that is 1. So binormal at 0, 1, pi would be this. So now let's go ahead. Now we have to find an equation of the oscillating circle. So let's just go ahead and look at our tangent normal plane, or what you call the osculating plane. Now the first thing to note would be this, that this center of the oscillating circle is going to be along this line, starting from P and going through a distance of how many units? 5 units, because 5 is the radius of the osculating circle. So if we have C as the center, the coordinates of C will be 0 plus 5 times 0 is 0, 1 plus 5 times negative 1 is negative 4, and then pi plus 5 times 0 is pi. So this is the center of the osculating circle, and the radius is 5. So what we have to do now is that we are in 3 dimensions. So first we'll find the sphere, okay, with center as this, and the radius equals 5, and then would take its intersection with the osculating plane. So let's look at an equation of the osculating plane first. So the osculating plane is the plane containing these vectors. That means a plane passing through this point 1, 0, pi, and here is our binormal vector. So it is a plane passing through this point and is perpendicular to this. So let me go ahead and make some space here. So we are going to write equation of the plane passing through this point and perpendicular to this vector, and the plane would be 2 times x minus 0 plus 0 times y minus 1, because second component is 0, plus 1 times z minus pi equals 0. So if you simplify it, the plane turns out to be 2x plus z minus pi equals 0. So that's an equation of the plane. Now let's get the equation of the sphere that has center C and the radius 5, and that I will just write directly by just using the coordinates of the center and the radius. So what that equation would be? So using again this and this, an equation of the sphere is going to be x minus 0 square plus y, then minus 4 is y plus 4 square, and then z minus pi square equals how much? 5 square, that is 25. So let's find a parametric equation of the intersection of these two. So for the intersection of these two, let's remember we just have to use ingenuity here, okay, and just by experience. So let's try x equals t. So what would that give us? That will, then we are going to find z, and then we will use those to try to find equation of y, value of y rather, so, or expression for y. So here we have this equation in z, t, and pi, and if we solve it for z, we are going to get z equals pi minus 2t. So what we may do now is this, just bring this equation here, okay, and substitute t for x and pi minus 2t for z, and then what that will give us, that is going to give us simply all these pi's will cancel, so this will simply become what? 4t square, okay, and then 4t square plus t square is 5t square. So we're just going with our algebra 2 techniques or algebra 1 techniques, wherever you did it. So this is 5, and what that gives us is that y plus 4 square is 25 minus 5t square, and the result is that y plus 4 is the square root, and of course that will be plus minus and then a square root of this quantity. So what y will be? Y is going to be negative 4 and then plus minus this value is square root of 25 square plus t. So what we have to do is, in order to draw the circle, we will have x equals t. So we will just have to have union of two curves. We'll have x equals t, and one of the curves will be, let's take the minus sign here, okay, and then z equals pi plus 2t, sorry, pi minus 2t, and the other half of the circle will be given by this, and change this negative sign to positive sign, okay? So what we are going to do is, let's just go ahead and graph this plane, the osculating plane, and graph the circle, and then we will have the whole graph as desired. All right. So we have to graph the curve, and then the tangent line that passes through this. This is the point on the curve. So passes through this point and is along this vector. So an equation is this. Likewise, equation of the normal line is this. And then for going forward for the binormal line, we have this equation, and then we got equation of the osculating plane and osculating circle. So let me quickly write all those equations down as a list for you. So let's just graph, these objects, the curve, tangent line, normal line, binormal line, osculating plane, and the osculating circle by using MATLAB. Now to graph this curve, first we have to do this, introduce a symbolic variable t, and then we just write the components as we have been doing, usually. And here I put the line width as 3, and for the color, this k is just the command for black colors. Line color I chose as k. All right, so this will graph this line for us, and we can say hold on, okay, and we can see the line later. All right, now we are going to graph the tangent line given by this equation. So what we would do is that we shall just use this command, and then, now one thing that we have to note is this, that here y is 1. But when we write the y component here, we have to write it in terms of t, and that's an easy way to do. Okay. Now, in this similar manner, I brought the command for the normal line, and I took here from 0 to 10 because 5 is the radius. I just wanted the whole diameter, and I'm color coding them in the sense that for normal, I'm taking the color red. For the tangent, I'm taking the color blue. Now here we have this for the binormal, and there I took the color black again. Now this will give us our osculating plane. And what I had to do was, first we have to take symbolic variables x, y, and z, and then have to define a function g of y and z, because we don't have any y in here, and even 0 times y doesn't work. So just define a function of x, y, and z, and remember, as you did before, f implicit of implicit 3 will give you a 3-dimensional graph of this plane, okay? Or you can graph it as f surf z equals pi minus 2x, whichever way you please. Now here I'm bringing, one moment, the two parts of the circle, and now we are getting ready to graph. So what we can do is this, that we can just keep, as we have been doing, the aspect ratio of the plotting box as this. We will keep axis equal, okay, and then let's go ahead and say Control Enter and see what we get. And well, Doesn't take too long. So here we are, and we will go ahead and open a bigger graph, and then here we are. Okay, and if you rotate it, you can see that we have this is our osculating plane, tangent line, normal line. This is our osculating circle, and this is the binomial vector. All right, and I'm going to put all the commands in the description window, and so that you don't have to watch this awfully long video. Just look at the commands and you know how to derive these things, and then just go ahead and do the graphing and make a better graph than I did. Most of the times you guys do make better graphs than I do.